Good afternoon to all of you. And now we will start our discussion on cryosphere. We had an excellent talk from Professor Srinivasan on general principle of climate change. And now we will move on and we will talk about the overview of cryosphere and the global distribution of snow and ice. Is it moving? Yeah. Okay. So one of the key, if you really go outside the earth and you can see that most of the earth is blue and that essentially it is a blue earth or blue planet. It is called because of the presence of oceans on the earth's surface, and this is a and most of the water on earth is also in the form of liquid. In addition to that, earth also has significant amount of water in the form of solid. And we know that what is it is a significant amount of water in uh, liquid as well as solid, and in atmosphere it is in form of vapor. So it's really important for us to understand. If you look into any other element or any other uh, mineral which is not in the form of three phases, cannot coexist on the earth. So in that sense, water is a unique element which is available in a three different form, and that is only possible because of concept which is known as triple point. That means as a earth pressure and temperature in such a way that it can really coexist all three phases, liquid, solid, and and vapor on the earth, and because of that, it's a unique one. So triple point of pure water is 0.01 degrees Celsius, and at that at 4.58 millimeter or 611 Pascal pressure. What it means is that there are numerous places on the earth which has a temperature, or at a given point, you will have a temperature sometime which is lower than this, sometime which is higher than this, causing this all the three phases to coexist on the earth and making it really unique. And therefore, we have a huge amount of cryosphere. And you know that because of this triple point, minor change in temperature can convert water from one phase to another phase. That means from solid phase, it can quickly convert into the liquid phase as temperature goes a little bit higher. And because of that, this is one of the most sensitive land features. So the cryosphere, which is where the water is in solid form, has a different forms, and they are seasonal snow. What it means is that most of the Himalayas are in northern hemisphere or southern hemisphere. The significant amount of precipitation in the form of snow takes place in winter, and in summer arrives, that snow melts, and such snow is called as seasonal snow. Then there is also sea ice. That means if you go into the Arctic part of the globe, you can see that there is a huge amount of area. Arctic Sea is covered by sea, and therefore it is a sea ice. Then there are ice shelves and ice sheet. What it means is that if you look into the Antarctica, which is nothing but the ice sheet, there is a huge amount of area, millions of square kilometer is covered by ice, and that ice get extended into the ocean, just like land gets extended into the ocean. Ice also gets extended into the ocean, and it makes as the ice shelf. Then there are glaciers and ice cap. So in Himalaya, there is a large amount of area is also covered by glacier, and they are basically controlled by topography. And because of they are called the mountain glaciers, so there are such a large glaciers are there. And it is on the top of the mountain, small area, relatively small area is also covered by glaciers, and these are called the ice cap. Then there's the permafrost, that means the land, the soil, the moisture in the soil remains under frozen condition. And because of that, such a huge land area is under permafrost. You can go into the Siberia or northern part of Canada, and as well as high altitude Himalaya, you can get the permafrost region. That means the soil which is in frozen condition, that the liquid water in that soil or soil moisture is really gets frozen. Then there are also on lake and river ice. That means large amount of lakes are also frozen during winter time, and the river water is also gets frozen. And in addition to that, there are ice crystal in the atmosphere. That is why we have snowfall. So these are the nothing but the various forms of the cryosphere, and why they are important, because they melt water to the rivers. It is a great indicator of climate change, and it can influence climate change also. It works both way. The cryosphere gets affected climate change, and the change in cryosphere can also increase the climate change. There is a significant amount of sea level rise. You can see that when the large amount of glaciers or ice sheet melts, it is quite possible that it can increase the sea level quite significantly. It also influences life on Earth, and as well as societal activity. We will look into those aspects as we move on in a further down on this lecture or a couple of other lectures. But cryosphere, as we know, is also interlinked with other Earth system, and these are like hydrosphere. That means if the glaciers melt or if seasonal snow melt, it goes into the liquid water, and it's a part of hydrosphere. That means part of overall water which is on the system. The atmosphere, there's a significant amount of ice crystal into the atmosphere, and they also create the snowfall. Then there's the biosphere. That means a significant amount of biosphere, particularly in a high altitude region as well as in boreal region or in alpine region of the Alps or mid-latitude region, is significantly affected because of the snow cover. Essentially because that region gets covered during winter time, and as spring arrives, the snow start melting and really changing significantly biosphere of the region, and supporting the all activities, not only flora and fauna, also significantly influenced. And the lithosphere is also significantly influenced because of the cryosphere, because we know that there are many issues related to the readjustment of the Earth's crust caused because of the significant departure of the huge ice mass on the Earth's surface. So that is the isostasy. So it is indeed all parts of the Earth, they are interconnected and they are influenced because of this. So one of the key ideas in this to understand is a water cycle. That means how water is distributed or moved throughout the Earth system. So if we can look into the water cycle, that means is the 97% of water is in oceans, only 2% of in snow and ice, and only 1% of that is usable. We will look into this issue subsequently later on. But you can see in a water cycle very clearly, it essentially, probably you can say that it starts with the evaporation into the ocean, then that further goes up into the atmosphere, leads to the formation of cloud, condensation, it moves into the land, and then it precipitates either in form of snow or maybe form of water. Here in case we talk about form of snow, then that snow either it forms as a seasonal snow, or it can fall onto the glaciers, and eventually that snow gets converted into ice and it moves, start moving. In addition to that, that water now comes into the plains through the rivers. Either it goes into the lakes, and even some of that goes into the groundwater, and eventually all of that either through evapotranspiration it goes into the atmosphere again, or sublimation in a glacier region. It goes, you can see here, in a sublimation, it goes into the atmosphere. Either it can go into the evapotranspiration from plant, or through groundwater, it can enter into the ocean, or through the rivers and lakes, it can also come into the ocean. So this is how the cycles gets completed into the see. So a key question is how much time it takes for that water to flow from one part to another part. And remember, this is also an important idea. So if you look into the ocean, which has a very large amount of water in it, and you can see that it takes approximately, it is a 97% of water is in form of ocean, and its mean thickness is approximately about slightly more than 2 kilometers. So it takes 3,000 years mean transit time, so that some of that water can go deep into the ocean and get it evaporated and come back again into the water cycle. It approximately gets 3,000 years. But the largest time it takes in the ice. So if it is formed, goes into the Antarctica and Greenland, it slowly gets converted, that snow, into the ice. It moves down the overall thickness and and it takes approximately 8,600 years. So you can see here that in an average amount of snowfall, which takes place every year, out of that, for last 8,600 years, snowfall is actually conserved in the form of ice into the glacier. So it really, transit time is significantly very high. If you look into the groundwater, there is a very small quantity of water in the form of groundwater, but it takes approximately 5,000 years to again come out and do the enter into the water cycle. Surface water is very small. It is annually. What it means is that this year's snowfall, rainfall, it melts and it again reaches into the system very well. Atmosphere, it is 10 days. You can see that a small atmosphere has smallest mean transit time, so quickly it gets deposited in form of rain or snow on the land. So that is how it takes. Therefore, ice, you can say, is a very long time. Transit time is for ice. Therefore, whatever water stored there, it is generally taken out from the system. So if you overall distribution, you can see that onto the earth, almost 97% of water is in saline form, and there is only 3% for water is in fresh water, which predominantly our ecosystem, or we use it for purposes. So out of that 3% water, 68%, you can see here, 68% water. Out of this 3%, 68% water is stored in ice caps and glaciers. So remember, these are far away from us. And then groundwater is a 30%, and others is 0.9. Out of that, other surface water is in only 0.3% is in form of surface water, and 87% is lakes, 2% is rivers, and swamp, it is 11%. So you can really see that humanity is working on very small percentage of water, which is water which is useful for human life, which is very small percentage of total water available on the earth. So if you really look into the earth, particularly in winter time, and if you are we have winter time in northern hemisphere and summertime in southern hemisphere, you can see that almost 32%, you can see whatever you see white here, almost this entire land cover, 30 to 40% of land surface is covered by seasonal snow. That means a snow cover. So snow obviously has very high albedo or reflectance, and because of that, it modulates the earth climate quite significantly. So you can see that seasonal snow has, when it fallen onto the vegetation, it can fall, and it can change its albedo, and almost 32%, 40% of Earth's surface is covered by snow. We also in Himalayas have a large amount of region where seasonal snow takes place. That is Jammu and Kashmir, Himachal Pradesh, Uttarakhand, Sikkim, and Arunachal Pradesh. These are the regions which receive the significant amount of precipitation in the form of snow during winter time. Remember one thing, that a snowfall when takes place when the whether it is a western system come into the west, into the Jammu Kashmir and Himachal Pradesh and parts of Uttarakhand, or if monsoon system which comes during summertime and precipitates snow in Sikkim, Arunachal Pradesh, and part of Nepal and Bhutan, uh, it doesn't melt very quickly. That means it remains there for some time, and it starts melting with a slowly over a period of time. And because of that, the water, which is predominantly seasonal snow, which is fallen in winter time, melts in summertime, and therefore many rivers such as Ganga, Brahmaputra, and Indus, they receive snow melt during hot summertime and making these rivers perennial. So that is very important for us to understand. So if we really look into this, that when the summer comes, almost 11% of land surface only remains of snow, snow and ice, and it is 30 to 40%. And it reduces to 11%. That means the large area of Greenland or parts of the Alaska and other North America or Siberia or Antarctica, that remains under snow cover. So it is from 40% it reduces to the 11%. So there's a significant variability in a snow cover takes place as we progress from winter to summer. So that is very important to understand. So one of the key ideas in this, that if you, because the large geographical area receives the seasonal snow, however, that geographical area doesn't have glaciers. Everywhere there is not glaciers. Glacier area is significantly small. So what it means is, the idea in that is, as summer comes, seasonal snow will start melting. But there are certain parts of the world where seasonal snow, where snow will not melt even in summertime. It means that during summertime, that snow will slowly get converted into ice. If it develops a sufficient mass of ice, because of the gravity, it will start moving. And that is when the glaciers are formed. So generally, if you move in a different parts of globe, approximately what is the, so height is required so that the temperature will be lower in summer, and then that snow line will remain there, and eventually with the passage of time that snow will get converted into ice. So it is very close to the ocean, mean sea level, when it comes to the South Pole region as when it comes to the North Pole region. And it is quite obvious because of the amount of solar radiation reaches on the both polar region is significantly small. However, as you move up towards the 30-degree north or 30 degrees south, there's a dry climate, and then this altitude keep increases and it goes as high as 5,500 meters. But remember one thing, many of you think that as we come to the tropical region over here, this is significantly reduces down, essentially because the climate is humid, and this as humid climate is there, the temperature index significantly reduces, and making it really a lower altitude also glaciers are possible. And as you move towards the further 30 degree, it again goes up, and then it slightly come down, particularly because of the monsoonal activity in Himalayan region. It is approximately 5,000 meters. You can see the region above which you can find the glacier. It's quite possible that glaciers from 5,000 meters will come down up to 4,000 meters. But remember one thing, it should have accumulation area in 5,000 meters to sustain the glacier. and it is because of the typical topographical region, glaciers can come down to 5,000 meters, but it is very rare to have a glacier whose accumulation area is below 5,000 meters into the Himalayas. So if you, those of you who are living into the South India, you can see that we have highest peak in South India is Anamudi Peak, that is in Western Ghat, and you can think how we missed by Whisker. You can go back and find out what is its height, and that is a reason why probably we do not have these glaciers in South India, but we have abundant glaciers in North India. We can look into that. So where are the glaciers? You know, the glaciers are distributed throughout the world, and the glaciers, probably you are aware, are nothing but the mass of ice which is slowly moving into the valleys, or they are moving because of the internal deformation, or they are moving because of the slope, whatever may be the reason for their movement, but it is a moving mass of ice. And glaciers have essentially ice, water, debris, all kinds of things are there, but its essential gradient is ice. It must have ice. So if you look into the ice mass in polar region, you have a large amount of Arctic islands in Northern Europe. You have Canadian Arctic islands, Greenland. These are the major ice glaciated terrain, and as well as you have a significant amount of glaciers in Antarctica in southern hemisphere. There are mid-latitude ice masses. They are in Iceland, they are in Norway, they are in Himalayas, Karakoram, Tibet. Then they are in Alaska, Pacific coastal part of Rockies, the Rocky Mountains, and then there are Alps. There are Patagonia in South America, and there are glaciers in New Zealand. So these are the mid-latitude glaciers. Remember, there are also glaciers in tropical part of the world. That means there are glaciers in Africa. So there are Kenya, Uganda, Congo, Kilimanjaro, and Mount Kenya. These are the regions where there are large, not very large, but there are glaciated areas. They are vanishing very fast, but there are definitely glaciated region is there. Then there are glaciers in New Guinea, Indonesia, the Ecuador, Bolivia, Venezuela, Chile, and Northern Andes. And so you can see that those regions where climate is humid, when there's a significant amount of moisture is there, and if you have sufficient amount of height into the mountains, it is also possible to have glaciers in a tropical region. So don't think that glaciers are only there in Arctic part or Great Himalayan mountain ranges or Alps mountain ranges. They are very much there in tropics. So if you look into the Africa, you will be there are significant amount of paleoglaciation records are there into the Africa, but there are existing glaciers. Whatever you see the red triangles, particularly in Mount Kenya and numerous other regions, where from the rivers originates, we can see there that glaciers are there in Africa, and which is reducing or decreasing very fast. When it comes to the Himalayas, Himalaya is nothing but the series of mountains. You can see that lowest mountain range is the Pir Panjal mountain range. You can see this is the Pir Panjal mountain range. So there are large number of glaciers in Pir Panjal mountain range. Then you can see there's another mountain range, Great Himalayan mountain range. You can see a red line. Then there is a Ladakh mountain range and Karakoram mountain range. So you can see the glaciers all along this mountain. It is important for you to remember that Karakoram mountain range, remember Karakoram mountain range, which is the northernmost mountain range, because we are going to talk and how they are geographically distributed into the Himalayas, because when we are going to talk future about various facets of glaciology, this terminology or these mountain ranges will be talked quite often. In addition to that, the region can also be classified on not only based upon mountain ranges, but also based upon the region. So you can look at Karakoram mountain range, Western Himalayan mountain range, then Central Himalayan mountain range, and Eastern Himalayan mountain range. So why that is important, because we will look into the next slide and a couple of next lecture, you can see that they are influenced by a different climatic system. It means that Karakoram is predominantly receives precipitation from western disturbances in winter. Then Western Himalayas predominantly from western disturbances. Central Himalaya is a mixed zone. That means it receives a certain amount of precipitation in winter as well as in summer because of Indian monsoon. And as we go towards the Eastern Himalaya, it is predominantly receiving precipitation in an Indian monsoon system. So making them climatically different zone, and it is influencing quite significantly climate change sensitivity are quite different for these glaciers or these regions. So it is important for us to understand this thing, and we will in future. So there is also issue of permafrost, about which we were talking about, and there is a large area. You can see here that this is a large area which is in Canada. This is a Canada and Alaska. You can say large area. Then this is Siberia. Large area is covered by permafrost. Some regions in a Greenland is also so permafrost. So there are some region in Norway and Sweden region is also facing the permafrost. So yes, it is indeed there's a large amount of permafrost there, and that is a significant. There is also ice on lakes. So there is a Pangong Lake. You can see that there's a significant amount of, particularly in winter time, what happens is the water which is it freezes, and the top layer of water is freezes. It's not that entire lake freezes. It's not like that. Only top layer freezes, and there is also ice on the lakes. So that is very important for us to understand, because so there are also, if you look into the ice masses in another hemisphere, one of the big ice mass is the Greenland ice sheet. You can see here, this is a Greenland ice sheet. You can see that it is a significant ice sheet is there, and this is one of the last remnant of ice sheets in northern hemisphere. And you can see it, if it completely melts, it can raise sea level temperature by 7 meters. And then there is then you have ice mass which is in a polar ocean sea. So Arctic Ocean, you can see that there is also significant amount of ice because water is completely frozen there, and it creates that. In the southern hemisphere also, there is a huge amount of ice sheets are there. So it is the Antarctic ice sheet. You can see there is a significant Antarctic ice sheet is there, and if it melts, it can raise sea level as high as 57 meters. So there is a significant amount of water is stored in there. So if you come into the mountain glaciers, such as Himalayas, or if you look into the morphology, they are significantly different morphology. If on one hand you have, we have a Greenland ice sheet or Antarctic ice sheet, and what is the difference between the Greenland ice sheet and Himalayan glacier? So, so what it really does is ice masses, when they are completely covered by basin, it means that there are certain minor undulations within the land. If you go into the Antarctica is not a plain surface. They are in Greenland is not a plain surface. They are undulating surfaces are there. There are some ridges, there are some valleys. Their size probably reduced because of the erosional activity of ice sheet, but the movement of ice is not influenced because of the underlying topography. When the thickness of ice is so large that its movement is not controlled by topography, and that is when we call it is a ice sheet. So we have right now only two ice sheets on the earth. One is a Greenland ice sheet and one is the Antarctic ice sheet. And their flow of pattern, it flows radially. That means you have a center which is a highest point where there is a maximum thickness, and it radially flows in all directions. You can see it flows in all directions. And if you can look into this, this is when you see it from the surface top, and if you take the cross section, you can see that this is a center. This point is this point, and it flows quite this way. So what it means is that if you want to go, it is very important for us to understand the flow of ice. Essentially, because if you want to know where is the oldest ice on this, probably you have to look over here. So, so that you can understand if you want to do the, as Professor Srinivasan was saying, we want to know the ice, what is the paleo climate, it is not good idea to come at the margin and dig the borehole. It may be good idea to dig at the borehole center or near to that, so that you can get the maximum thickness as well as the oldest ice. Then also what happens is when it becomes a very large ice mass, it starts flowing down and it flows into the sea. So you can see here this ice, which is anchored to land here, but this is extended further down into the ocean, and this is where the water is. This is where water is, and that ice mass is floating onto the surface. So, and then the third category that is you can see is ice masses constrained by topography. So you have most of the Himalayan glaciers are constrained by topography. That means you have huge valleys, and they have mountains, and in between the mountain there are valleys, and there's annual snowfall. That snowfall remains there for a few years, gets converted into ice, and it flows only in one direction, because that is the valley, the rock, surrounding rock, not allowing it to flow in any other direction, but in direction which the valley is there. And because of that, these ice masses constrained by topography, and they are called the mountain glaciers. So you can see that there are ice sheets and there are ice caps on the earth. So as of now, there are only two ice sheets I was talking about, and there are 70 ice caps on the earth. Then there are ice shelves and ice rises. Then glaciers constrained by topography. There are on Earth, there are almost 200,000. Then there are ice field, transactional glaciers, transection glaciers, valley glacier, Piedmont glacier, Cirque glacier, glaciers, ice apparent, and rock glacier. We will look into this terminology slowly and steadily. So we have looked into this this slide, that how it flows and how it's this is Greenland ice sheet, or Antarctica Greenland ice sheet, and one side is this side is a Greenland ice sheet, and this side is the Antarctic ice sheet. You can see here one of the if you can look into the Greenland ice sheet, is not sufficiently large to extend into the ocean, and it is not extending into the ocean. There is a land surface around the Greenland ice sheet, which is where the human habitation is there. But particularly in Antarctica, there are many places where ice is extended into the ocean, and which is called the ice shelf. And here it is showing the flow of glacial ice, which is common whether it is in Greenland ice sheet. And you can see here in much more detail that how this ice thickness, this is the ice flow, then there's the ice shelf, and eventually some of that ice shelf gets converted into iceberg, and you see that some of the tragedy in older days has caused because of this this calving of icebergs, and eventually they enter into the ocean, and creating navigational hazards for the many people. You can also see in this cloud the grounding is somewhere else, and its extension into the ocean. So here it is a grounding, and it is on the ground, but it is extended into the ocean. So this is the idea of ice here. And this is the ice of Vatajucal ice cap in Iceland. You can see here that this is a fairly large geographical area, but you can see that glaciers are in all directions. Glaciers are coming out from there, so there are a large amount of glaciers are there. There are also tidewater glaciers into the Alaska. What is the meaning of tidewater glacier is, this is similar to the ice shelf, but it is a mountain glacier. It is not really a big ocean like Antarctica, but it is a small glacier extending into the sea, and you can see that it is an interface is between the glacier terminus. This is a glacier terminus with water. So when the glacier that terminates into the sea, then it is called a tidewater glacier. So we can see it, and then there is a calving, and then there's a huge amount of icebergs are formed, and they can be entered. There are also small ice fields distributed throughout the globe. Ice fields are something which is on the top of the mountains, and they are small in size. The snow remains there throughout the year, and it eventually gets converted into the ice. So it is not sufficiently large enough to convert into the certain form of glaciers, but there is ice, and there is a small glacier there. So these are the ice field. So you can see here that this is an ice field in a large geographical area, which are on top of that, and sometimes they are interconnected, and sometimes they are not interconnected, but their flow pattern is significantly governed by underground topography. And that is what Professor Srinivasan today is talking about, because of under such circumstances, it is possible that if glaciers reduce its area, it is possible it can provide water from one valley to another valley, and creating, at least locally. So this is one of the picture of the valley glaciers. You can see this is a SAMUDRA TAPU glacier into the Himachal Pradesh, and this is what I was talking about, the constraint by topography. You can see here, this end there is a huge mountain, this side there is a huge mountain, and glaciers is flowing through the valley. Glacier is flowing through the valley, and because of that, it is a valley glacier. It cannot flow any other direction, but particularly in one direction. And the glacier bounded by walls of valley and descend from mountain. So they come from high region to the low region, and we will learn about these terminologies about accumulation area, moraines, and ablation area in subsequent slides. So what we can say here is Earth has a large amount of perennial ice, and you can see here one of the biggest perennial ice is Antarctic ice sheet, which has approximately 13.3 into 10 to the power 6, so almost 34% of total water, and its volume is 24.5 million cubic meter, and if it melts, approximately 56 meter. Greenland ice sheet, then a mountain glacier ice sheet, permafrost ice sheet, permafrost. So a total 38.9 million square kilometer area is under the perennial ice or under the cryosphere on the Earth. And if it melts completely, then the sea level will rise by almost 64 meters, and that is a huge rise in sea level. But predominantly, it is coming from Antarctic ice sheet, which has a 56 meter, and it has a maximum thickness, which is a 4,000 meter. Then there's the Greenland ice sheet is 7, and the Himalayan, including Himalaya, Alps, Rockies, or Patagonia, you can see it is slightly less than 1 meter. It can raise the ice, and permafrost is a much more than less than that. However, that does not mean mountain glaciers are not important for human civilization. Essentially, they are very crucial because, particularly in context of India, because Himalaya has a large concentration of glaciers, and these glaciers melt, particularly in summertime, making our river perennial. As well as there are different facets of this, and all these facets and the importance of glaciers, particularly Himalayan glaciers. We will explore that in next slide. In a next talk. But importance is, you must realize in Himalayan glaciers is hydropower, irrigation, and drinking water. It can, if I can conclude by saying that, then there is a glacier melt, which is a contributor to sea level rise. Retreating glaciers can create hazards, either in form of avalanches, flood, or it can create the iceberg. It can affect the albedo, and it can modulate the climate. In a climate point of view is also very important. Glaciers keep a good record of past climate. Therefore, they are very important to assess the paleoclimate. It also creates the landscape. They forms the erosional and deposition landforms, and the cryosphere affects the ecology. How they affect ecology, we will try and see that in a next slide. So with this, I would like to thank and take some more questions.